Okay. So, first of all, thank you for coming here. My name is Álvaro Hernández. Just came here yesterday night, but I've been coming to Russia quite frequently in the last few years. So that's I'm very happy to be here. And I should know by now some Russian, but not very much. So I will go in English if you don't mind. Before starting, so how many of you here are Oracle users or somehow administer some Oracle database? Okay, maybe around half. Thank you. And how many of you are Postgres users or administer Postgres servers? So maybe even less. And how many of you want to migrate these Oracle servers to Postgres servers? Yeah. Okay, so I guess that's part of the reason you're here today, right? Okay, how many of you have actually performed an Oracle to Postgres migration? 1, 2. Okay, so, 3 there. Okay, so those of you who have already done this, please correct me if I'm wrong, which I will probably be. Because it's quite a large topic. There's many things to talk about. And one of the goals I have with this presentation, you know, when I was preparing it, I was researching and double-checking all the other Postgres talks that are available online about Oracle to Postgres migrations. There's quite a few. And all of these presentations tend to focus on some, I would say, 2 key parts, which are definitely key to the migration process, which is how to migrate PL/SQL to PGCQL. That's quite frequent, and that is quite a hot topic and quite a big topic. And the other one is performing the schema and data type conversion, which is, of course, very important too. So I believe that there's more or less enough material in these areas. So, of course, I'm also presenting it here today, but maybe in a shorter form. Because, again, there's many other talks, many other tutorials focusing on this. I believe there's a ton of material. It's maybe pointless to repeat everything. More or less, I'll go over a summary of these topics because, of course, they are important. But especially, I wanted to focus on one of the topics where myself with my team, and I will introduce that later, have been working lately in Oracle to Postgres migrations. And I would say it's quite novel. However, it's quite important, which is the live migration, a migration without a downtime. There's not a lot about this covered on other talks and other tutorials, other presentations, and that's the reason I wanted to present it today. How to do these live migrations, which tools to use, what the technologies are based on, and what are the caveats in doing live migrations. And at the same time, there's also one topic that I wanted to cover in this presentation, which is to describe a real use case, a real migration of a large scenario. And so here today, I will make a summary of the process that we did for a very, very large company, even though it may not sound like very large as of today, which is Blackberry. But yes, they are alive, they are still there, and they actually have an application, BBM, which has more than 150 million users. And we migrated them from Oracle to Postgres in actually quite an impressive scenario, from on-premise to the cloud, from Canada on-premise data center to the cloud on Indonesia. So with a high latency link. So it was quite a challenge. And the requirement was almost 0 downtime. So I will present this use case as an interesting scenario of how to perform this kind of migrations. So this is the 2 main topics I wanted to cover here that are, I would say, quite novel in terms of other Postgres presentations. So again, I will touch on the topics, of course, of PL/SQL to PGCQL migration. I'll touch on the topics of data types and schema conversion, but I will make a stronger focus on the live migration part and presenting a real use case and describing the architecture. And, you know, because migrations sound too theoretical when you see in a presentation like this, but then when you go to reality, things are totally different. So that's what I would like to present. Before that, and if Ivan, morning, allows me to take a very, very short 30 seconds to introduce you, sorry for the self-plug, new community conference that was announced 2 days ago that I am running. And it might be interesting for you, especially today, looking at the weather, which is actually definitely warm. I am definitely disappointed. Always that I'm coming here, this time I'm expecting at least -20, and terribly disappointing. But still, we are organizing a conference on a warmer place, on a warmer time of the year. So, do you know the island of Ibiza in Spain, Mediterranean Sea? Yes? Can you imagine a Postgres conference there? Well, it's going to take place. So, just for your information, just go to pgibsat.io, and this is a conference, Postgres conference, on the beach. For the first time ever, Slonik is going to the beach. So if you like Postgres conferences, if you like nice weather, if you like Spanish Mediterranean delicious food, this is a new Postgres conference coming out in June 20th and 21st. You're more than welcome to go there. In case you forget, I brought some vouchers. I mean, just for remembering the conference. They're here with me. Come and grab one so that you will not forget the conference. And check out Twitter because we'll be posting all the topics there and all the follow-ups. So feel free and go and grab one. Sorry for the self-plug. All right, so let's go back to the Oracle to Postgres topic. And just before starting, I'll briefly present myself. As you know, I'm Álvaro Hernández, or Álvaro. This is my Twitter address, you can see on the screen. I am the founder of a company called Postgres, which means on top of Postgres. So we developed products and services around Postgres. That's the only thing we do, Postgres. We have done crazy stuff, like we created Project ToroDB, which is a database to migrate data in real time from MongoDB to Postgres, using actually a technology called Change Data Capture, which I'm going to be talking a lot today. And this project transforms JSON documents to relational structure real time. And we're also working on a project called PostgreSQL. Actually, it's PostgreSQL code.nf. It is a web page and later on an application to help you tune Postgres. And I will talk a little bit about today about how important it is to tune Postgres after or for an Oracle to Postgres migration. And I'm going to many Postgres conferences and member of the Postgres community. So that's another reason why I'm here. Still, seems like Postgres community still don't know that I'm Spanish and I wake up late, so it's hard for me to give a talk early morning. But anyway, here I am. All right, so let's get started. There's a few topics I want to cover here today. This is more or less the agenda. So first of all, we're going to briefly discuss the reasons to migrate from Oracle to Postgres. I guess you already know these reasons or actually have experienced them or have discussed them, but just in case. And then we're going to go like step by step to present what is the stages or what are the dimensions that you need to consider for a successful Oracle to Postgres migrations. Actually, also all the talks focus on some technical parts of the migration. I want you to give you an overall perspective of all the journey for a Postgres to Oracle migration. And then, so we're going to start with the first part. We're going to talk about the assessment. The assessment is a necessary part of the migration. This is a process of generating some information, understanding the environment, and concluding actually whether the migration is even possible or not. And what could be showstoppers in this process. Then we're going to look at some differences that you may experience from an administrator perspective. and then differences in SQL. After that, after understanding what is the difference from a DBA perspective and from a developer perspective, we go into the migration process. For this, we will talk about the schema migration first. Then we will go into data migration, and which is the main topic I want to bring today. And within data migration, we're going to discuss the differences between offline migration, which is the one that mostly everybody talks about, and the online migration. And the difference is significant. Offline migration involves downtime. And downtime is basically proportional to the size of your database. If you have a several terabyte database size, your downtime is probably measured in the order of hours. Hours of downtime are not acceptable for many. I would say for most. So it's actually not even a possibility. Of all the migrations we have done for our customers, none of this was an option. They couldn't afford 4 hours of downtime. That means typically a lot of high cost for a high transactional enterprise. So it's not possible. So we're going to discuss about live migration, which involves almost zero downtime. And then, of course, we'll also talk about PL/SQL to PL/PGCQL migration. And finally, I will present this use case where we migrated Blackberry from Oracle to Postgres. There will be a break in the middle to be relieved from me for a while. Needless to say, please interrupt me anytime. It's not that we need to wait until the end for questions. Raise your hand and we'll go for the questions. That will be better, more interactive. Okay, so why to migrate? The first reason is quite obvious, cost. Do you know what is the cost of an Oracle license? List price. So Oracle does some discounts. So don't take this exactly. But the list price that Oracle offers for their database, basic version, no rack, no in-memory option, no data guard, just Oracle database, is $40,500. So just imagine this number, right? And multiply by the number of nodes. Actually, you also need to multiply by the number of cores, because that price is per core. Yeah, that is the price per core, almost $50,000 per core. That means that if you have an 8-core machine, the price for the Oracle license is $400,000. And that's a small machine, that's a small server. Multiply this by, take a database with 16, 32, 64 cores, take 3, 5 servers, and you are in the order of millions of dollars. Of course, then you'll get maybe a 70% discount, which Oracle typically does, and it will get down to only 400,000. Such a bargain, right? Let's go and buy it right now. Can do it out of my pocket. But not everybody can afford 400,000, 600,000, $2 million, $10 million. That is not a surprising contract for Oracle at all. So taking into account the cost of Postgres, which is 0, right? That is infinitely cheaper. But mathematics aside, is a very strong reason. Not everybody can afford these licensing prices. But other than the cost, there is the terms of the licensing. Of those of you who mentioned that you use Oracle here, have you had a visit in your offices of these men in black? No? Well, be aware because this could happen. So if you haven't read in detail the Oracle licensing terms, which I guess you haven't, first of all, because probably you're not in the compliance or legal or procurement or decision-making department, even if you are, it's a 100 pages or 50 pages or with full of legalese term that nobody understands. If you look at item 12.1.4.3a, of course I'm making these numbers up, it says that by abiding by Oracle license, you allow Oracle employees or Oracle-appointed companies that perform as auditors to knock your door, enter your office, yes, like this, literally. They knock your door, they enter your office, and they check all your computers. You need to give them access to all your computers, and they will check what Oracle products you're running and whether you're compliant with the license that they have. And, of course, what happens if you're not compliant? What happens if some even development machine that someone decided to put it into production was using Oracle and you didn't have a license for that? Guess what? You're going to need to pay for that. And you're going to need to pay a premium for that because you were in violation of the license. And I've seen really, really aggressive cases. I've seen cases where some Oracle discovered that you were using some Oracle software. Doesn't even need to be the database, of course. Could be anything else. And you didn't have the appropriate license. So Oracle says that in violation of the license, you need to pay for this, obviously, but also retroactively for the last 5 years, including support, even though that support you're not going to be obviously using. And then when your bill is like this, then maybe they will make you a discount if you paid in that moment. And abide to renew all these licenses for the next coming 5 years. So they really get you trapped. And really, this is not a myth. This happens every single day. Oracle has created a business of companies who go and audit Oracle customers and find them for non-compliance. And I can tell you they are strict. Oh man, they do their job. I had one of my customers had this problem. Let me digress a little bit because I think it's quite interesting to understand why this is such an important reason to migrate off of Oracle. It's a client who only has one Oracle database running on Solaris 9 since I don't know how long time ago. But it's used for the payroll of the company. Nobody wants to change that. Payroll is only used once per month, but it works. And you know, people want to receive money at the end of the month, so it's an important system. And the software that runs this payroll is super old. Nobody wants to upgrade it. Nobody wants to touch it. So far, so good. It's running. Okay. One day, this man in black, or maybe woman in black, came to my customer's office to audit the compliance for the licenses. So far, so good. My customer said, no problem. Here's the Oracle database. Here's the license. All good. Yeah, all good. But let me ask you a question. This database has the payroll, right? Yeah. So you take backups of that, right? Sure, of course, it's a payroll. We take backups. Ah, okay. Where do you store these backups? Oh, you know, we have a Windows, this is a Windows company, actually. And they have a Windows shared drive, CIFS, and you know, we put it there. Oh. You know, actually, if you look into the license and you look at item 12.4.5.2.1b, it says that the places where you store copies of Oracle-produced files also require a license. What? Yeah. This basically means that the computer you're placing your backups also requires an Oracle license. So you require 2 licenses, not 1. Wow. Okay. Okay. Well, you know, give me that license, or I'll pay for this license. How much is it? Because actually, you know, Oracle has a license per user by that time. So he said, okay, I only need 1 user, right? No, actually, you know what? There's one problem. Because right now, the Oracle licensing terms have changed. Now you pay per processor, not per user. Or like, but my original database is per user. Yeah, but the Oracle license, now you cannot do that. You need to pay per processor, which is this 47,500 I told you before. And actually, so I need to bring you to Oracle 11. I was like, but I'm not using Oracle database. It's just to store the backups. It doesn't matter. But I'll give you Oracle 11 license. Okay? Oracle 11, 1 processor, 47,000 list price. Okay. Oh, you know what? There's another problem. you cannot have an Oracle 11 with an Oracle 9. Both need to be the same version. So also need to upgrade you to this 11. So you need to pay twice. And then they switch also the license from users to cores. So basically, just because you were storing backups on a separate drive, they basically sold list price $100,000 to Oracle licenses. Then they got a discount, and maybe it went down to 60,000. So this is one very strong reason to migrate off of Oracle. They're very aggressive business tactics. And this is the reason why most people are migrating off of Oracle right now. Not even the cost, the licensing terms. And the problem is that Oracle makes this very easy to make mistakes. Have you tried to download Oracle software? You can download anything. The most expensive version of their software, you can download at zero cost. Just log into Oracle website. So you need an account, and you can download anything. And why is that? Because when you download, you need to register. When you register, they know who you are. They know where you are. If they believe that you're using this software in production without a license, they will knock your door. And they will be able to enter in your office. So that's partially how they work. They let you very, very easily make mistakes and then pay for them. The in-memory option of Oracle 12c, they changed that. But when they released 12c, it had an in-memory option. To use it was as simple as clicking, oh, yes, I want to try this very cool in-memory option. That cost you another 50K per core. And it generated logs that, oh, you turn this one, even for 1 second, you turn it on just to click, like by mistake, and you need to pay that money to Oracle. It's like this. So that is one of the reasons to migrate off of Oracle. Then there's another reason. This is more philosophical, but actually it's very important. Do you know what Oracle does with your data? I mean, do you have any warranty that Oracle is not sending information out to some agency in the US? Most likely not, but who knows? It's proprietary software, right? We cannot check the source code. We cannot see how it's done. And actually, Oracle's president and founder, Larry Ellison, has mentioned many times that he's a fan of the NSA, that he supports the NSA, this agency in the US that has spied on many people, including some European leaders. So I believe if they do something bad with your data, someone would have noticed already. If they would be sending information back to the NSA, someone may have noticed. But there's no warranty. And do big enterprises, do governments want to, take this risk? Probably not. So this is another very strong reason to go with an open source database. Because within an open source database, there's no question. You can inspect the source code, you can see if there's anything wrong. You can modify it yourself and make sure your data is yours. And also, Oracle is not available on every cloud. So if you're actually migrating to the cloud, the only place where you will actually see Oracle database as a service is in Oracle Cloud, obviously, and Amazon. But that's it. There's no Oracle as a service on Azure. There's no Oracle service on GCP, on Google. And there's no Oracle service on many other platforms. So you're more limited if you want to go to Oracle. So if you want to migrate off of Oracle, and you're going to an open source database for all the reasons mentioned here, which database would you pick? Well, I know that this is a Postgres conference and you came to this talk, so it's obvious, but why? Why Postgres and not MySQL or any other database? And the main reason is because Postgres is such a natural fit for Oracle. They share a lot of similarities. SQL compatibility or similarness is very high, and there's support for stored procedures. So it's much more of a natural fit than other relational databases like MySQL. There's actually an ongoing effort at MariaDB to support PL SQL, the same PL SQL that Oracle supports. but it's very basic as of now, and that's a great effort. I like it. And that will ease this part of porting stored procedures, but there's huge differences in terms of SQL and also in terms of administration capabilities. And what can I say? Postgres is a I would say, much better database anyway. So it's a safe bet to migrate from Postgres to Oracle. And actually, some people may think that, Postgres is kind of a low-cost option to migrate off of Oracle. That, you'll pay less, but you will get something kind of not that good or not that performant. This is also a common belief. I would like to dismantle this belief. Exadata. Have you heard about Oracle Exadata? So Exadata is supposed to be the best platform for a database in the world, the most powerful machine ever built for a database, built by Oracle, targeted for the Oracle database. It is quite impressive. If you look at Exadata specs, they are second to none. It's extremely expensive system, obviously, and is tightly coupled with Oracle software, installed by Oracle, managed by Oracle. It's the best database on earth, according to marketing. I have migrated 2 Exadatas to Postgres. Many people didn't believe that. It's impossible to do that. It is possible. Postgres is really, really good if you tune it appropriately. So could also support these loads. So don't worry about that. Postgres is second to none and can handle very demanding workloads, and you can migrate comfortably and safely from Oracle to Postgres. All right, so let's start with the process. How do we start with the migration? First of all, we need to go for a migration assessment. So what is a migration assessment? An assessment is the process of basically understanding and analyzing the Oracle environment. What this Oracle environment has, what services, what technologies is using of the Oracle database, what functionalities. Because in general, if you look at the array of features that comes with Oracle, it's impressive. Many of those are not available in Postgres. But that doesn't matter if they're not being used. So this is the question. What is being effectively used? For features that are not used by this given migration, we don't care, obviously, right? We also want to identify showstoppers. There's a few showstoppers. If some of this happens, then you definitely need to forget about the migration. It cannot happen, right? And also to estimate the complexity. Some migrations could be done of course, very, very, very simple stuff could be done in a few days, but normally migration projects take any time from 2 months to 1 year. And you need to understand whether we are talking about a couple of weeks or 2 years, right? So we need to understand. And the migration assessment phase is used to estimate precisely what is going to be this cost, what is going to be this effort involved, and why. Where did this come from? So how to start with this assessment? The first thing you should come up with is a questionnaire. A questionnaire where you would ask the users of the Oracle, if they're customers of yours or if it's an internal, how they're using the database. What technologies, what products of Oracle are they using? Whether they're using RAC, whether they're using Active Data Guard, what are the sizes of the database? The applications, they are more transactional, they are more data warehousing oriented. What are the sizes of the instances of the databases, the number of users, the applications accessing those applications, whether the applications are internal or they are provided by ISVs, by vendors. All these questions you need to ask in a systematized way to gather some information about the environment. And then it is interesting to use some tools that are available out there at no cost that will introspect the Oracle database. They will connect to the Oracle database, look at all the metadata, and bring information about all the tables, all the views, all the schemas, all the triggers, all the procedures, all the objects that are available inside the Oracle database, and they will give you an estimate also of the cost and effort. You will understand the magnitude. It is not the same to migrate a schema of 2 tables than a schema of 50,000 tables. It is not the same effort. It cannot be, by obvious reasons. The same with the lines of code. If there's no PL SQL code or just very simple triggers of 10 lines of code, which are just basically incrementing a sequence, that's very straightforward to port to Postgres. If we're talking about a project of 100,000 lines of code or 500,000 lines of code of PL/SQL, which procedures of length of thousands of lines of code, that is a big effort. And you need to understand this. And there's some automated tools that will help you to provide this information. And last but not least, you need to understand the performance of the database. Is this database being very actively used? How are the rate of changes happening to the database? How many gigabytes per unit of time are being produced by changes in the database? How many corrections are being used in the Oracle database? So we need to also understand the performance, because otherwise we don't know how to dimension the Oracle database. So for the assessment part, as I mentioned before, the first step is to start with a questionnaire. Once you have the questionnaire, because this is human, right? You send it to the group of humans who administer this Oracle database, or you do it yourself if you're in that group, then you should go and do the assessment, the automatic assessment. There's a couple of tools that can help you here with. One is Ora2PG, which is very well known in the industry for Oracle to Postgres migrations. And we're going to talk a little bit more about Ora2PG. And Ora2PG does this function. Connects to the Oracle database, will inspect all the objects, and will tell you the complexity, the number of objects, and some comments about them. So basically, I don't know if this is a pointer. Yeah, kind of. So here you can see that there's this is a report, an example report generated by Ora2PG for the assessment part. And you'll see all the objects here, like database links, functions, indexes, and it will give you a count, whether there's some problems or some things that cannot be mapped into Postgres. What is a cost estimation? Actually, cost estimation by Ora2PG, I wouldn't take it very seriously. There's ways of actually passing some parameters to Ora2PG to adapt your cost estimation. But even with that, estimation is hard to be automatic, to be honest. Always humans do a better job here. So, but otherwise, you get some comments, you get some details. This is, for example, the functions you have there. This gives you a pretty good overview of the objects that you have in the database, and lets you estimate the complexity. Then, if we're talking about dozens of objects at most, you can actually inspect those manually. You can go into each of those objects, look at them manually and say, okay, you know, the cost of this migration is going to be in this ballpark because there's 20 objects. I have looked into all these 20 objects and I've seen them. And then you guess how they are. If you're in the order of hundreds or thousands of objects, which is unfortunately more normal, then you need to do another kind of estimation. But even then, typically, the work of estimation, the complexity of the project involves looking at almost all of them manually. And the way to do this, even if there's thousands, of course that means you may spend some time even just on the estimation, but it's important because you need to understand whether this is a 2-month work or a 2 years work. One good pattern that I would recommend you to use is to look precisely to try to categorize the objects into beans. So let's say there's 5 degrees of difficulty from very easy to port to very complex to port, and try to count these objects into these beans, and then you assign different costs to those. So you say that, you know, for example, talking about procedures. If they have like 10 lines of code, 20 lines of code, maybe you can port that in a couple of hours, including some testing, or 3 hours, or 1 hour. Really depends on how you're doing things. And if super complex ones may take you a week, including all the testing. There's several thousand lines of code. And then you need to inspect those manually and quickly bin them into these categories. And with that information, you can then perform the multiplications and all the calculations. You'll get an estimation of the effort to port the database. So this is more or less how you can do this, and Ora2PG will give you an assessment, and that will help you to perform this estimation. The other tool that can help you here is the schema conversion tool that comes with the DMS, the Data Migration Service by Amazon. So Amazon has the service called DMS, Database Migration Service, which supports migration of many databases to many databases. There are several tools in the market that perform this. The advantage of this tool is that it's free, provided that either the origin or the destination is on the Amazon cloud. It doesn't matter if it's a managed service or a non-managed service, but if you are either the source or the destination, or of course both, are on the Amazon cloud, you can use the DMS, the Database Migration Service, for free with Amazon. The good news is that this tool is a tool to capture the schema of the database, and is a separate tool. It is a tool written in Java, and so it runs on almost any operating system. And this tool is separate. And unless I'm wrong, there's no restriction that you need to use it on the cloud. So you can use it, basically. And it's quite handy, and you can also get some estimates. So actually, it's good to run both, and then combine the results of both running Ora2PG and the AWS, the schema conversion tool, the SCT. It's interesting because this tool actually provides you some hints on how to change the code, on things that need to be changed the code, and can actually perform automatic conversion of some objects, the same as Ora2PG. They're both quite handy tools. And about the performance, there's a tool by Oracle called AWR, Automatic Workload Report, that gives you a lot of insight into the performance of the database. And this is also very important because it's not the same, you know, for moving a database off of Oracle to Postgres. The configuration in Postgres, as I'm going to mention after, is very important. And it's not the same if there's 10 connections doing almost nothing on the database, or there's thousands of users doing concurrent changes to the database all the time. And this tool, which comes with Oracle Enterprise Manager and can be set up programmatically to perform reports every hour, take snapshots of the database and the reports, performance reports, compare them, it's actually quite complete. It takes a little bit to understand how the information is presented, but once you're familiar with this tool, it provides a lot of valuable information. So it's included with almost all Oracle licenses, so just go and use this tool, because it will give you a profile of the database, and it's quite important. So, what are some showstoppers? There may be others, but what can prevent you from actually doing an Oracle to Postgres migration? You've done the questionnaire, you've done the assessment, now you're in the position to tell whether the migration is possible or not. So there's mainly two reasons why a migration may not be possible. One is if the Oracle database is using TDE, transparent data encryption, and that is a must. If you really need to use, for compliance reasons, transparent data encryption. As far as I know, there is one of the commercial Postgres versions, the Fujitsu Enterprise Postgres, that supports transparent data encryption. I don't know if any other version right now supports it, but vanilla Postgres doesn't for sure. So if you want to use vanilla Postgres and you want data encryption, transparent data encryption, then this will be a showstopper. If the requirement would be just encryption at rest, then you can definitely encrypt the volumes where the Postgres data directory will be, and then you're good to go, and there will not be a problem at all. But if the requirement is to have encryption at the database level and not at the storage level, then this would be with vanilla Postgres as showstopper. The other, it's quite obvious. We're talking here that the migration from Oracle to Postgres requires application changes. We're going to need to change the SQL. We're definitely going to change the source, the driver, how to access the database. A migration is only possible if you can change the application. If you cannot change the application, it will not work. So you need to access the source code of the application. This means that all the tools that are proprietary, unless they specifically support Postgres, you're out of luck. Specifically, all the tools that Oracle sells, guess what? They don't support Postgres. And so far, so good, right? So if you cannot change the application, even just to change the driver, you'll not be able to migrate to Postgres. Now, there are some other issues that people typically consider as showstoppers, but they are not. One is Oracle RAC, real application clusters. RAC is both a high availability and write scalability mechanism for Oracle. And it's very widely used because it was marketed very well. But the reality is that there's other ways to achieve high availability, even in Oracle, without RAC, with basically active data guard. And the right scale and capability, very few people really need it. And actually it's very limited anyway by design, by the architecture in which Oracle RAC is based. It cannot provide significant write scalability anyway. So the question is, do you need this for Postgres? And the answer is typically no. So it's very, very easy. There's no significant difference in migrating off of an Oracle running on RAC to a normal Postgres instance. As long as you have the right sizing of the instance, the right disk, the appropriate performance, you do an appropriate tuning of the database, you'll be good to go. So sometimes this question arises also. Do I need multi-master in Postgres? Well, there's definitely some ongoing efforts to have multi-master in Postgres. There is Postgres XL, which is a native cluster, multi-master clustering solution for Postgres. It's not one of my favorite tools anyway, but it's there. There's also, I believe, a multi-master effort by Postgres Pro. So that will be multi-master on Postgres Pro version of the database. But as I said before, in many cases, what you need to do with Postgres is to scale out the reads, because you can offload to read replicas, and tune appropriately and size appropriately the master instance, and it can handle a really large amount of write load. And you can even scale out with all the other Postgres projects like Citus, and you scale and you shard basically your writes. So there's many ways of getting around this limitation, but most often, this necessity, this need for write scaling for multi-master is more of a buzzword than a real need. Most people who claim that they need this, they don't need this. They run very, very well on a single write instance. And as I mentioned already before, Exadata. Exadata is called the machine. It's really impressive specs, and we have migrated 2 of them. They may not have been the biggest Exadata in the world. They were just significantly powerful machines, but that's it. It's not the end of the world. And you can typically migrate also Exadata to Postgres. Questions so far? No? Okay. So let's look at a few differences from what would be the administration perspective of Postgres, from a DBA perspective. What changes when you go from Oracle to Postgres? Well, in general, Postgres is a very natural fit for Oracle DBAs. If you're used to run Oracle and you go to Postgres, you'll feel quite comfortable. Actually, if you go the opposite, which is the one I've mostly taken, I'm not an expert in Oracle anyway, but at least I know some things about Oracle. And it's like, wow, this is super difficult, or super verbose, or you need to do 10 operations to accomplish the same effect that you accomplish in Postgres with a very simple command. But other than that, it is a very natural fit. They are quite similar databases conceptually. However, the way you use them is totally different. The tooling is completely different. And it requires some training. So you need to understand how Postgres works and why it works this way. So for example, Oracle can be deployed mostly without problems with basic default configuration. You may tune the SGA area, which is basically the memory, and a few other parameters, but you're typically good to go. Postgres is not the case. Postgres, you really need to make a significant effort in tuning Postgres. If you take a Postgres with the default configuration and run it in production as is, that's like, you know, like having a Ferrari and not being able to go beyond the second gear. You know, like going at 130 kilometers per hour on second gear. That's it. You know, it's totally underperforming. So Postgres needs to be appropriately tuned. There's almost 250 parameters that you can tune in Postgres, and you definitely should tune several of those in the order of 30, 40 to get really great performance out of the database. This is a topic I'm personally super interested into, and I've given many talks. If you're interested in tuning Postgres, look for a talk I've given at several conferences. There's slides online, there's video. It's called Postgres Configuration for Humans. Just if you would be interested on this, just search for that. You'll find some extra material. So configuration tuning is quite important. But so it is connection pooling. So let me ask you actually, how many of you that run Postgres here do tuning of Postgres for more than, let's say, 5, 10 parameters? No one. Okay, look for this presentation. You'll enjoy that. And how about connection pooling? How many of you that use Postgres use connection pooling? Okay, someone. And who don't use connection pooling? You have to understand who of you run Postgres? No? Okay. Oh, a few. Okay, so there are some cases where you might not need connection pooling in Postgres, but most of the time you need connection pooling in Postgres. The architecture differs from Postgres to Oracle or MySQL databases. And the number of concurrent connections that you may have by default without connection pooling to the database is lower in Postgres than in Oracle MySQL. So while something could be normal to see in an Oracle database a few thousand of connections, which is not good anyway, they also require connection pooling and perform much better with connection pooling. 1,000 connections on a Postgres database will probably lead to bad performance, even on very beefy machines, and could actually lead to very significant problems. And if you go to the orders of tens of thousands of concurrent connections, you're killing your Postgres. Postgres will still work, but definitely under the performance that Postgres could be with. However, if you front Postgres by a connection pooler, even those 10,000 connections going through the connection pooler and waiting a little bit to be processed in Postgres land, they will perform so much faster, so much better. So this means that you can still throw 10,000 connections at Postgres simultaneously, no problem. You just need a connection pooler or several connection poolers in front of that. So this is just a different topic, don't want to get into it right now, but just bear in mind that from an architectural perspective, you might want to have almost always connection pooling in front of Postgres and good configuration tuning in front of Postgres. This is something that typically, or not always, is performed in Oracle the same way. And regarding the tooling itself, it's also a significant difference how the tooling works. Oracle tooling is, of course, mostly Oracle-based. Most of the tools that are more widely used with Oracle databases are produced by Oracle, and they come with Oracle database. So it's, once you install the thing, you have it all. An Oracle install right now weighs about 3.5, close to 4 gigabytes compressed. A Postgres install typically weighs around 20 megabytes. Yeah? So where's the difference? And the difference is mostly around tooling. Oracle comes with a lot of tools. Probably most of them you will not use them anyway. And Postgres just comes with the basic tools that Postgres comes with. So where Postgres gets the rest of the tools to work, where do you get the production environment ready? Where do you get the stack the set of tools that you need to provide all the capabilities that an enterprise database requires, for a production requires. And it's basically on the ecosystem. Most of these tools, most of these functions are not provided by Postgres itself, but rather by third parties that are part of the this Postgres ecosystem. For example, you want high availability. There are several tools to choose from, but none of them come with Postgres. You want connection pooling. There are several tools that don't come from Postgres, but are available. You want monitoring. There's so many tools that are also available in the ecosystem. You want backup solutions. There's many. Go to again to the ecosystem. And this is a totally different shift of paradigm for Oracle DBAs. They're used to a solution that brings all the tools together, and they're all used together, and in Postgres land, this is totally different. And this is both an advantage and a disadvantage. The advantage is that you have a lot of options to choose from. The disadvantage is that you have a lot of options to choose from. Yeah. We have a lot of customers that spend a lot of time and require our services just to understand which tools to pick, because picking the wrong tool could be better than having no choices. I'm sorry to say, but there are wrong tools out there. So, some other basic differences that you may find between Postgres and Oracle databases. First of all, the memory cache area called the SGA on Oracle, called shared buffers in Postgres. This is basically the cache, the data cache. They don't work exactly the same in Oracle and Postgres. But the main difference is that in Oracle, you typically make this area quite large, a significant portion of the RAM of the database. Whereas in Postgres, you typically want to use a significantly smaller part of your memory of the database. I don't like this rule of thumb that says that you use for shared buffers 25% of your memory. Sometimes it's better less, sometimes it's better more. But it's usually not a significant percentage, because Postgres has 2 layers of buffering. This shared buffers, which is a Postgres-aware buffering. And then there's a file system buffering, which is OS managed and is data or Postgres independent. And this double buffering does not work well with a lot of pressure or with a lot of really big allocation for the shared buffers. Similarly, the Oracle redo logs and the Maxwell size parameter in Postgres, which seem like totally similar, they are not. So in Postgres, the Maxwell buffers is basically the amount of space that we keep for the wall records, the durability logs. And they affect basically the distance between the checkpoints. Checkpoints are the process in which Postgres will manage to reconcile the information that is in memory with the information that is on disk. And that also affects the recovery time if the database would crash midway. But other than that, there's no significant user consequences. As a user, you may see worse performance or better for performance tuning Maxwell size, but there's no other effects. However, in Oracle, the redo log operates differently. And it is also used for the wall process, but it comes together with the undo. And the undo is what allows Oracle to keep a transaction open for some time or go back in time if you're doing a query in the past. And the size of this space will determine for how long you may keep a transaction open. So there's definitely user visible effects by sizing differently this space in Oracle, whereas there is not the same effects in Postgres. With table spaces, the story is similar. In Oracle, table spaces are integral part of the database, and you may create a lot of those. In Postgres, table spaces are just a name for a directory. And they're only useful if this directory is sitting on a different drive. So say, for example, you have rotational drives and you have SSD drives, or you have normal SSD and you have NVMe, faster SSD drives. You might want to create table spaces on these different drives and assign the tables or the indexes to the different media by putting them into different table spaces. But if you're not doing this, if you have a single drive or a single virtual drive, which is the same performance profile, don't use table spaces, because they make in Postgres life much more complicated, or not much more, but more complicated. And they can also affect the way you take backups. They can affect several things. So if you don't have these different media with different performance capabilities and you want to pick tables and indexes going to different parts, then you should not use table spaces in Postgres. And as I mentioned before, you're using Oracle RAC is not needed in Postgres normally. Questions? No? Okay. SQL differences. There's more than the differences that I'm going to be mentioning here today. But this is just like a quick overview of some of the differences. I don't want to get into the details of these. You should, of course, when you're porting an application from running on Oracle to running on Postgres, inspect all the SQL that is being used in the application. There's actually tools that will help you kind of do an advanced grep and find queries among your source code and help them translate to PostgreSQL. But this is a topic on its own. And actually, what we have found so far is that most applications that are running on Oracle are using an abstraction layer on top of it, typically an ORM, that abstracts you from writing SQL. And by changing with this ORM the engine from Oracle to Postgres, you will basically incur in zero cost migration for the application part. This is good for migrations. This is typically not good for the applications because ORM tend not to be very good at their job, except some notable exceptions like Duke. But for migrations, they're very, very handy. And most of the time, there's these ORMs being used. So you don't need to deal a lot with these things. But anyway, it is a topic on its own. SQL is a standard, but everybody knows that the standards are only there not to be fulfilled. And specifically, SQL standard has extensions and has had extensions and has had vendors developing their own capabilities before the SQL was standardized and so forth. So there is differences and you need to account for those. But actually, so here I'm going to give you some differences that are real, that are actual. But the most significant differences, I would say, is of the functionality that you might not be using. Postgres in general is a much richer database in terms of data types, in terms of capabilities in general, and very similarly in SQL. And when you're migrating from Oracle to Postgres, the first thing that you will probably not do is use specialized data types. I'll show you an example. So, talking about the SQL language itself. Both databases are quite good with SQL. If you look at the SQL standard and you see what implements each database, you will see that both are doing very well. Both databases implement most part of the standard, and they're conforming with the standard in general. They have extensions, both of them, but in general, they implement the standard and works well in these regards. And both, of course, have this procedural language that we will discuss later. So from this perspective, the SQL available is similar. The problem is some obsolete syntax that specifically Oracle has that comes from long time ago and it's still being used, and can sometimes be tricky because it's being used by some applications. Like for example, the plus symbol to specify a join in Oracle. That was from long time ago, and right now you can just use a join as a SQL clause, but still there's a lot of code out there who contains this plus symbol. This plus symbol will not work in Postgres at all. So you need to transform this into a real join. So this is, by the way, a process which some tools already support. So one tool that is very common in the Oracle world, it's Toad. It's a graphical tool, can help you translate this automatically. I haven't tried it myself, but I know it works. Similarly with the code, there is a function which is called the code, which is kind of a case. and you can transform this into a case. More or less straightforward, but you still need to go through the code and do this transformation. And obviously row count. Row count is very widely used in Oracle. It is not a good practice anyway, and there's a way to handle this in Postgres. I'll also mention a little bit about this before. So, data types. This is a very important topic, because if you look at Oracle data types, and let me actually show you something. So, if you just look at the Postgres data types, let me look for the, of course, documentation in the current version. The Oracle data types are basically 5. You have varchar2, which is for character strings up to, if I recall correctly, 4,000 characters in length. You have number for numeric quantities. You have date for dates and timestamps. And you have the binary fields, which is the CLOB and the BLOB for binary data, and for longer character streams, the CLOB. That's it, 5 data types. If we look at Postgres data types, let me make this bigger. Well, there's numeric types, all these in this table. There's like 10. Monetary types, 1. There's character types. There's basically 3. They're basically the same, but with some differences. There is the byte A as binary type. There is several for date and time with timestamps. There is Boolean types. There's enumerated, geometric, network, for text, for bit string, UIDs, XML, JSON, arrays, composite types, range types. Well, you're just reading the website, of course. There's dozens of data types available in Postgres. Do you know that there's a, I mean, this is very normal, but anyway, how many of you know that there's a data type in Postgres to manage and to validate and to store very efficiently network ranges and network IPs in Postgres? Yeah? Yeah. And MAC addresses and geometric shapes. You know, there's a lot of data types. None of these are present in Oracle. You store them something else, or some other tools. So this is the most significant difference, how to map these data types. So, I'm talking about number, for example. Number in Oracle is very generic. Can store both small numbers, big numbers, floating point numbers. And in Postgres, you have specific data types for all of this. You have ints of different, from 1, 2, 4, 8 bytes. You have single floating point precision floating data types and double precision data types. And you have arbitrary precision data types with numeric. So when you face a numeric in Oracle, you need to see what it belongs to in Postgres. And here's where most of the tools will not help you completely or not help you in the good direction, because if you don't know the data, you don't know exactly which data type to pick. And so oftentimes, a numeric in Oracle is going to be transformed into, a number in Oracle is going to be transformed into a numeric in Postgres. A numeric in Postgres is a data type very rich that will allow you to use any number of, a very, very high number of digits and, you know, hundreds of thousands of digits. Very, very, a lot of the precision after the decimal point, but it's also very slow. So you need to be aware of these conversions and make sure that if you're converting from a number in Oracle to a numeric in Postgres, you might want to convert that to an integer or to a float or to a double, depending on your use case, and you may need to inspect the data. So it's not enough to run the tool and say, oh, I've got the schema converted, let's go. You may need to look into the data and see whether the types are appropriate. And number is one of those specific items that you should definitely review. Same with date, times, timestamps. Probably in Postgres you want to use timestamp with time zones. That's also an important recommendation. Oracle, because there has a limit of 4,000 characters in text fields, a lot of users tend to avoid varchar2 and instead using a CLOB. A CLOB is a less flexible data type for storing basically text, and it is not a good practice, but it's used a lot. I mean, fortunately, the tools available will migrate CLOBs, but it creates some problems. Specifically, depending on the size, you need to adjust some parameters and to grab them in some chunks. But you know, it's better if there's no CLOBs, but there's typically CLOBs. One important thing that it's, by the way, sorry, not mentioned in the slides. The slides will be uploaded after my talk to speaker deck. You can tweet me, send me a tweet, and I will do that also to show the slides are. But there's one very small caveat here. Postgres strings do not support the UTF-8 null character. They're called the 0 character. This is very specific to Postgres, and if you may have data which contains this null character, and this happens more often, then you'll not be able to migrate that data to Postgres. So you need to find a workaround, either to find the offending rows and update them, or to put a placeholder, or to do something else. But you can definitely not store UTF-8 in Postgres. Sorry, UTF-8 null character in Postgres. You can do that if you store it as a binary field, but you very likely don't want to do this. It's what it is. I would like this limitation to be removed from Postgres, but I haven't tried to push for this, and I got pushed back. It's also interesting to understand that Postgres and Oracle are strongly typed databases. They enforce data types strictly, so you cannot insert, you know, an integer into a text field or vice versa. They provide casting mechanisms, so you can convert one data type into another one if the representation is appropriate, obviously. But by default, they are strictly checking the data types. Surprise, that Oracle provides a lot of implicit conversions which might not be obvious. So by, you know, the data type itself is strict, but operations between data types may not be. And you can perform an addition of a text string which looks like a number with a real number, and that will produce a number. Or a text with a number that will produce a string. And all these things work, and the results are quite surprising. So just be aware of that. It's a bit like, if you allow me to say that, it's a bit like JavaScript, which is hard to predict the outcome sometimes. And it's very messy. Postgres does not allow this. You will need to use explicit data conversions. Another confusing part is in Oracle, you know, what represents null? What is the meaning of null? Who can tell me? Oh, thank you.
Okay. Well, first of all, we must understand that in a relational theory, we have three types of values. It's true, false, and unknown. Null is unknown.
Exactly.
And if we try to compare something with null, we will get unknown. Not true, not false, but unknown. And the only operator in Postgres which gives you not unknown is distinct from, is not distinct from. And it may be a trap because, for example, in Oracle, like you said, empty string is null, and you must handle this case in Oracle specifically. And in Postgres, null and empty string is different things. And if you don't know this, you may write the wrong code when you try to migrate from Oracle to Postgres. For example, in our customers did a great mistake which led to infinite cycle when they tried to convert a hierarchical query. Well.
Yeah, that was excellent answer. Actually, you already did the whole slide. So null is an unknown value. It is not a missing value, as some people may think. It is, according to relational theory, an unknown value is undefined. There is a value, but we don't know what it is. Or there might be a value, right? So, of course, if you try to compare null with null, that can never be true because a known value, you don't know for sure if it's equal to another unknown value. The problem is that in Oracle, an empty string, or in other words, a string of length 0, it is the same as null. So this comparison here, empty string is null, returns true, and everything gets confusing because an empty string, it is a known value. It is a string which is empty, right? So the empty string compared with the empty string in Postgres yields true, right? And surprisingly yields false in Oracle because it is null. So it's interesting. So the empty string is compared to null, and because null is not equals to null, then the empty string compared to the empty string is false in Oracle. Why this is like this? Yeah, I know. Yeah, I know. And this comes from long times where for efficiency reasons they decided to implement this. And then actually if you go to the Oracle documentation, it makes things even worse because it explains this as, if you treat zero length characters as nulls, when you do a concatenation, what is the result of a concatenation operation over something that contains null? Well, null, because you don't know. If you add something you concatenate something to null, the result is also unknown, right? So if you call null unknown, you'll understand how this works, and then something concatenated with something unknown is unknown. Well, in Oracle, because of this, concatenating a zero-length character string with another operand results in the other operand. Wasn't it null? So I'm getting lost here. So if it's null for some things. However, for other things, it's not null. And it gets confusing, right? Because here is like null, here is like null, in a concatenation is not like null. Now, the funny part comes here. This may not continue to be true in future versions of Oracle database. Yeah. So this is a problem. It's very inconsistent. Some places is like null, some places is not like null, and this all may change in the future, but we don't know when. Beware of this. And this is also interesting. A function that receives an integer, you pass it an empty string, and that works. Because guess what? It's null. So, yeah, it's very messy. That's all I can say. Postgres is consistent. So, and there's a lot of usage of this in application code, and you need to deal with this. Okay, another topic about queries themselves, the query optimizer. One assumption that typically holds is that, oh, okay, I have done all these, I've checked all the queries, I rewrote some of them, and now they're already in Postgres. They will perform the same. No. Both databases have different optimizers and query executors. And while most likely they will perform potentially similarly, because they will potentially be smart enough to take similar decisions, and then performance is more bound by the disk or the performance of the system than the database software itself, you may find some surprises. Some queries may start performing better in Postgres, some queries may start performing worse in Postgres. So actually a critical part of an Oracle to Postgres migration is to actually measure the performance in testing scenarios, of course, before going live. Because it might be surprises, right? It's interesting because Postgres optimizer is kind of simpler than Oracle, and that is good and bad. It is good because it takes less time for planning, so query execution does not take a lot of into planning time. But at the same time, for complex queries, it might yield to worse plans than Oracle. So, it's what it is. You may want to check these two parameters maybe sometimes you need to increase them to allow Postgres to do more complex planning if you're running with complex queries. With a lot of nested clauses, which are also very typical in Oracle, like a lot of nested subqueries. You might want to increase these parameters to improve performance here. The other difference is that Oracle, because of this extra cost in planning the queries, has an internal cache, which helps avoiding planning the query more than often. And actually, you can achieve the same with Postgres, but more from the client perspective by using prepared statements. So you need to use the software, the drivers, or APIs that will use prepared statements in order to achieve similar benefits. You also don't always want cached query plans, because depending on your parameters, you might want to select other plans. But in general, they provide performance advantages. So you might also want to make sure you're using prepared statements. And about the functions that comes with the databases. Postgres is quite rich in terms of functions. If you go to the website, the Postgres website where I was before, showing the data types, and you do the same for functions, you'll see dozens, hundreds of Postgres functions that are available. And you can use them, scalar functions, set returning functions, and so forth. You can use it as part of your queries, and you get rich functionality. But Oracle is a beast here. And it comes with tons of packages full of functions. You can do everything from the database. And not everything you can do is probably a sensible thing to do. It is not uncommon to find people and teams who send emails from the database. Really, to open a network connection within a transaction. Which means that if the network connection is flaky, the remote server is not behaving correctly, or the network I/O is slow, your transaction will slow down everybody. Will hold logs, will hold resources, will do crazy things. Just to send an email. No, emails should be sent by the application. But you cannot believe it. This is one of the most common discussions with customers about Oracle to Postgres migrations. No, you need to send emails from the application. Yet there's an extension for sending emails from Postgres, but I still don't recommend it. So this is the main problem when doing a migration. It's not the SQL code itself. It's not the data types that you need to change them. It's the use of Oracle functions that come with the Oracle database that have no equivalent in Postgres. That is the most challenging part, because you're going to need to avoid the use of these functions in the new code or to re-implement these functions in Postgres. Good luck is that there's a project called orafce by Pavel Stule that has implemented quite a few of these functions that are very typical in Oracle land. So if you face the use of these functions, you can go to orafce, and then you'll import those functions into Postgres, and you'll have a similar functionality. It's not designed to be 100% compatible. It doesn't have all the functions. It doesn't have, for example, the function to send emails, but it has a nice set of those. So it's not bad, and definitely is a very nice helper. More stuff. Folding case. So everything in Oracle is uppercase by default, right? Is that actually when you're working with Oracle database, you feel that everybody's shouting at you all the time because it's uppercase, right? Postgres is lowercase. Everything by default is lowercase. So yeah, guess what? This creates a mismatch. So the good news is that, of course, Postgres is quite flexible, and you can have uppercase, lowercase, mixed case. You can do whatever you want. But then you're going to need double quotes. So most frequently, tools and teams who translate some application from Oracle to Postgres, in order to simplify the rewriting, keep everything in uppercase. Understandable, but try to avoid that if you can, or if your migration process can change this into lowercase, you'll be much better off. Because when you need to administer the database, when the DBAs are going to need to fix an issue in production, where you just need to log into the database, you're going to need to type double quotes and uppercase all the time. And that's significantly much less efficient. So it is an option. Postgres can do well with uppercase by quoting everything appropriately. But if you can avoid this Oracle-ism, I would recommend you to do that. Indexes. This is also an important topic because there's no one-to-one mapping between the Oracle indexes and Postgres indexes. The B3 indexes, yes, they're everywhere, and actually both Postgres and Oracle support advanced functionality on indexes, like expression indexes, but there's differences. For example, Oracle that has bitmap indexes. And this is something that a lot of people ask for. Oh, how do I create this bitmap index in Postgres? And the answer is that you don't need a bitmap index in Postgres, because actually Postgres will create bitmaps for scans by itself automatically in memory. You don't need to worry about that. Just create a normal B-tree index if that's needed. But at the same time, Oracle has index organized tables, which is a mix between an index and a table. Tables that are always organized according to an index. So you don't need an index to actually get an ordered version of the table. Postgres does not have anything like that. You can actually use the cluster command to rewrite a table according to an index, but that has two significant drawbacks. The first one is that the order will not be preserved with new insertions. And second, that the cluster operation takes a very heavy lock on the table and it's not recommended. So basically, you should almost never use this unless you want to cause downtime on your database. And as such, we can safely assume that Postgres does not have indexed organized tables. Postgres also creates implicit indexes when you use a unique constraint or something that implies unique, like a primary key. So that means that when you're porting the code to Postgres, if you specify something that is a primary key or a unique, that will create an index on that fields. But if you're also having the create index statement, you will end up duplicating this index. It is not the end of the world that duplicated index. This causes some slowdown on insertion or in general modifying performance, and of course uses more disk space, so it's not the recommended. Postgres will still work, but take care of that because I've seen many duplicated indexes just because of this reason. Also, by default, Oracle performance on search on the strings is not bad, whereas Postgres index string search without a specific index search, or when you're not able to use a normal B-tree index, is not very good. Luckily, there's specialized indexes for searching text in Postgres, like the gene index with the trigram operations, and then it becomes very good performance. So there is typical slowdown perceived when moving from Oracle to Postgres when dealing with search on strings, because again, in Oracle works more or less well. In Postgres, you're required to create a gene index. So you may want to consider, for these cases, use this gene index with trigram operations, for example, because that will index. We'll be able to use the index with queries using like the like operator with percentage before, and so forth. You may also consider, related to the case folding, the CI text extension, which is extension for Postgres, which creates a data type which is case insensitive. CI case insensitive. So sometimes, because you're dealing with this Oracle that everything is uppercase or lowercase, sometimes there are mismatches that this extension, this data type, can help you with the CI text. Could also be interesting. And then, of course, because Postgres has many more data types than Oracle, index types than Oracle. It doesn't have IoTs, doesn't have bitmap indexes, which are not needed because they have them anyway, but has different kind of indexes. Has hash indexes, which are good for equality reasons. Has Breen indexes, which are very good for big data sets in which the indexed column or columns are more or less inserted according to a natural order of the data. Has the gene indexes, which are specialized for some data type, like text or arrays or JSON. Has the gist and SPGist, which are more generic frameworks for specific indexes. They're using, for example, in GIS with PostGIS. And you can even create your own index in Postgres. You can definitely do that. So there's a lot of variety here. And some last bag of things that you may find in the SQL difference between the tables, the databases. The dual table. This is a virtual table that exists in Oracle, and you may find it in queries. In Oracle, you cannot say select 3. You always need to do select whatever from, and if you don't want to select from a real table, you need to select from dual. So there's maybe a lot of queries that are select blah, blah, blah from dual. This will not work in Postgres because dual does not exist. So you typically want to remove this. orafce brings the dual table, but it's better to remove that and not keep that legacy into your code. Oracle has this concept of synonyms. It's just an alias for a name to basically put it on the global schema space. And well, there's basically two ways to work around synonyms in Oracle, in Postgres. Actually three. The first one is I wouldn't do it. I would just always fully qualify the table name, schema name.table name. You're good to go. Don't use synonyms. It's just to shorten the table name. Okay, it's a small return. But you can also simulate synonyms with schemas, which is a different concept than in Oracle, and using the search path mechanism, or even using views and putting them on the public schema. There's several ways to do this, and depending on your use case, can work. What about database link, database connections? It's also more or less frequent in Oracle to have a connection from one Oracle database to another Oracle database. And then there's a way of connecting those and performing queries across databases, which is called database link. Well, in Postgres, there's two ways to accomplish this. One is using the foreign data wrappers infrastructure, in particular the Postgres FDW, which allows you to connect from one Postgres to another Postgres and perform queries across both databases, and works well. There might be some performance implications there, depending on the version of Postgres specifically that you're running, and also the type of queries that you're doing. But in general, works well. But you may also consider using different schemas, because Oracle cannot do this because it has like separate stuff, separate instances. Whereas in Postgres, you can also have the same levels or similar levels of separation within the same database by separating into different schemas with different permissions. And in this case, sometimes could be equivalent to separate within the same database in different schemas. And in this case, you will get better performance. So it could also be interesting. As I already mentioned before, the row num. Row num is also used a lot in Oracle, doesn't exist in Postgres. You can use window functions to simulate this. You can also use limit and offset. But take care if you use limit and offset, because there's very bad anti-patterns when using limit and offset. And if you're aware, my good friend Marcus Vinant has a movement called a society called No Offset, which is to prevent the use of offset within queries, because typically they lead to very bad performance. So if you're interested in this, also look for that on a search engine, the No Offset, and you'll find the reasons. And there's also in Oracle connect by, which is basically like a common table expression with recursive. So it's basically a recursive query. It's also supported by Postgres. Yes, instead of saying connect by, you say with recursive. That's a little bit about SQL, data types. We've seen the migration assessment. How are we doing? Questions? No? Are we good for a coffee break? I think it's needed, right? Okay, so let's stop for a coffee break. More or less, I think the break is half an hour, so we'll continue around 12. Thank you.